Alright, so here's your chapter 10 quiz review. Alright, these first three problems I'm going to be doing on part A of the test. And then when I switch to part B, which is the second worksheet, I'll let you know so you can change over. So for now, make sure you're using part A. So number 3, that was the first one y'all wanted. We need to find the area of this trapezoid. Alright, well, area of a trapezoid, the formula is 1/2 the height times the sum of the bases. Well, we have the sum of the bases, it's 26 plus 14, but we don't have the height. So we're going to find the height. Well, the height is this dotted line right here, which makes a nice 30, 60, 90 right triangle. Alright, let me blow that up a little bit. So this is 60 degrees. Here's our right angle. We know this is 6. Alright? So now we're going to find out what side this is. Well, since we know that, since this angle is 60, we know this angle is 30. And so the 6 is the S in the ratio. Because remember, a 30, 60, 90 triangle, the ratio is S times the square root of 3, and 2S. So since 6 is across from the 30, we know it's S in the ratio. Since our height here is across from the 60, we know it's S times the square root of 3 in the ratio. And we don't really need to find the hypotenuse, which is 2S. So since we know that the S in the ratio is 6, we know our height is simply 6 times the square root of 3. Alright? All I got to do is use this ratio. 30, the S is across from the 30, which makes that 6. And then across from the 60 is H, which is S times the square root of 3. So since S is 6, it's just 6 times the square root of 3. So that's our height, 6 square root of 3. So you're going to put 6 square root of 3 right here. And now we're going to solve it. So 26 and 14 is 40. 1/2, 6 square root of 3. Though you can half the 40 down to 20. So now this is 20 times 6 to the square root of 3, which is 120 square root of 3 inches squared. Alright, that's it for number 3. Remember, you got to remember these ratios for these 30, 60, 90 triangles. And for the 45, 45, 90 triangle, your ratio is S times the square root of 2. So both sides in the 45, 45, 90, both sides are the same length. And the hypotenuse is simply a side times the square root of 2. Alright? So this is number 3. Your answer is 120 square root of 3. Alright? Let's move on to the next one. I'll leave that up there for a while. Alright, number 5. We need to find the area of a kite. This is 4, this is 6, this is 10. Now the formula for area of a kite is 1/2 diagonal 1 times diagonal 2. Alright, so 1/2 diagonal 1, doesn't matter which one you call 1. Let's call this one 1, that runs from here to here. So that means the total length of this diagonal is 10 plus 4, which is 14. And then this diagonal, now this big one bisects this smaller one. So since that's 6, that means this is 6 as well. So 6 plus 6 is 12. Alright, so you can half either one of these. Alright, so 7 times 12 is 84. Over the units, meters. Alright, so remember for a kite, this is the kite. Formula for a kite. Now, your formula for a rhombus is the exact same formula. It's your area is 1/2 diagonal 1 times diagonal 2. Now remember, in a rhombus, the diagonals bisect each other. So if you look at number 4, the shorter diagonal will be 15, because that's 7.5 plus 7.5. And the longer diagonal will be 16, because that's 8 plus 8. Alright? So it's just 1/2 diagonal 1 times diagonal 2. Remember, the longer diagonal in a kite bisects the shorter diagonal. That's how I knew this was 6. So this diagonal is 12, this is 14. 12 times 14 times 1/2. 7 times 12, 84. All right? That's number 5. Let's look at number 6. Number 6 is finding the area of a parallelogram. Alright, so here we go. Remember, formula for area of a parallelogram is just base times height, just like for a rectangle. Because think about it, if you were to take this triangle here, chop it off and move it over here, what would you have? You'd have a rectangle. So it uses the same exact formula. Now remember, your base and your height are they have to be perpendicular to each other. So what you need, the first thing you need to look for is a right angle. So you're looking around, oh, here's the right angle. All right, what two lines, or what's the length of the two lines that make up that right angle? Well, one of them's 5, and the other one is this line here, which is the same length as this line here, which is 13. All right, so the answer is 5 times 13, which is 65. And then feet squared. All right, so just remember that in a parallelogram, in a rectangle, even in a triangle, your base and your height will always be perpendicular to each other. So look for that right angle and see which two sides meet at that right angle. That would be the 5 and the 13. Because like I said, this top side is also 13. Alright? Alright, let's look at number 8. Number 8 is kind of a hybrid problem. We have a triangle sitting on top of a rectangle. This is 8. This is 5 by 22. Now, what you need to do here is split this into a triangle and a rectangle. So area of the triangle is 1/2 base times height. Area of the rectangle is just base times height. So let's do the triangle first. 1/2, what's the base? So what's the length of this? Well, it's 22, because we know this is a rectangle, so we know that has to be 22. Times the height, which is 8, because again, you look for that perpendicular angle. Okay? So you can half the 22 down to 11, so this is 88. Base times height here is 5 times 22. Okay? Which is, let's see, 5 times 20 is 100, 110. So now all you're going to do is add these two numbers together to get the area of the whole figure. 198 inches squared. Alright, so just break that up into a triangle and a rectangle. Find the area of the triangle, find the area of the rectangle, add them together. That's it. Alright, let's keep going. Number 10. Number 10, we have a hexagon, regular hexagon, with a side length of 20 centimeters. So what we need to do is we need to find the apothem. And that's all we need, because remember, your formula is area equals 1/2 apothem times perimeter, and since we have a side length, we can easily find the perimeter. Alright? So, we have to find out what this angle is. We know this is 10, we've got to find out what this angle is. So you're going to do 180 divided by the number of sides. We have 6 sides. So it's 30, so that means this is a 30-degree angle, which means this is a 60-degree angle. So again, you go back to your ratio. Since the 10 is across from the 30, it's the s in the ratio, which makes the apothem s times the square root of 3. So a is simply 10 times the square root of 3. So now you have everything you need. 1/2, 10 times the square root of 3, times your perimeter, which is 20 times 6, so that's 120. Alright, if you want, you can half any of them. Let's make that 60. So this is going to be 600 times the square root of 3. And they wanted your answer rounded to the nearest tenth, so you're just going to type this in your calculator, multiply 600 by the square root of 3, you should get 1,039.2 centimeters squared. Alright? Because remember, just punch this into your calculator and make it convert it to a number. Okay? And then just round that number to the nearest tenth. So again, this was just your 30, 60 on your triangle. Alright? This was 10, it's across from the 30, that means it's S. This is across from the 60, so it's S times the square root of 3. So since this is S, this is just 10 times the square root of 3. Your perimeter is 20 times 6, so 120. Half the 120 down to 60. 10 times the square root of 3 times 60 is 600 square root of 3. Just type that in your calculator and multiply it out. 1,039.2. Alright. Let's look at 12. 12, we have a hexagon. I'm not going to draw out the whole hexagon because basically it all boils down to this right triangle. Right? This is half your side length, this is your radius, and this is your apothem. Alright? We have a side length, which is 4, which means this is going to be half our side length, which is going to be 2. Alright? Now to get this angle, we just do 180 divided by our number of sides. Well, our number of sides is 8. So 180 divided by 8 which is 22.5. And now we want to find our apothem. Well, we're going to have to use trig here. This side here, our apothem, since it touches our angle, is our adjacent side. The 2, since it's on the opposite side of the triangle, is our opposite side. So opposite and adjacent, we're going to use tangent. So the tangent of the angle, 22.5, equals opposite over adjacent. Remember, the shortcut when this is on the bottom is just to switch the two sides. So A equals 2 over the tangent of 22.5. Okay? So let's keep our answer non-rounded, so I'm going to leave that there for now. So now we just set up our formula. A equals 1/2 the apothem, 2 over the tangent, 22.5, times our perimeter. Where our side length is 4, we have 8 sides. 4 times 8 is 32. Alright? So this 2 and that 2 will cancel out, leaving you 32 over the tangent of 22.5. So punch that in your calculator, round it to 1 decimal point. 32 divided by the tangent, 22.5. And you should get 77.3. What were my units? Meters squared. Okay? If this confuses you, don't do it. Just type 1/2 times 2 over the tangent of 22.5 times 32 in your calculator, and you should also get a 77.3. I just cross-reduced before I multiplied, because why multiply up? Just to divide it back down. Okay? So the 2 on the top cancel with the 2 on the bottom, makes that a 1. This becomes 1 over 1, so this is practically gone. And then 1 over the tangent of 22.5 times 32, the 32 just goes to the top of the fraction, and the tangent of 22.5, of course, stays in the bottom. Punch that in the calculator, you get 77.3. Alright? Let's look at 13. Again, you're just worried about this triangle, and we know that this is 8. So we need to find this angle. Remember, 180 divided by the number of sides. We have 5 sides. So that's 36. So this is a 36-degree angle. We need to find our apothem. Also, we need to find our side length. So we're actually going to have to do this problem twice, and I'll show you why. Well, to find the apothem, this is the adjacent side compared to the 36-degree angle, because it's physically next to it, and this is the hypotenuse. So adjacent and hypotenuse, that's cosine. The cosine of your angle equals adjacent over hypotenuse. multiply both sides by 8. So 8 times the cosine of 36 equals A. Now to find x, since this is on the opposite side of the triangle, x is your opposite side. So opposite of hypotenuse, that's sine. So the sine of 36 equals opposite over hypotenuse. Multiply both sides by 8. So 8 times the sine of 36 equals x. Alright? Now, let's not round our numbers. So let's keep these numbers in this form until we're ready to type the whole thing in the calculator, okay? So, 1/2 A equals 1/2 our apothem, 8 times the cosine of 36. Now, remember, this is only half of our side length. Because remember, this extends on before it goes back up for the other side. So this is only half our side length. So for 13, we have 5 sides. It looks like 4 of them holding the marker. So we have 5 sides. And since this is half our side length, we have 2 halves per side, so we have 10 halves. So we're going to take this number, multiply it by 10, because we have 10 halves all the way around. Okay? So that means 10 times 8 times the sine of 36 is 80 times the sine of 36. Okay, if you want, you can half that 80 down to 40. And now just type that into your calculator. Make sure you use the parentheses correctly. Alright, here, hopefully you can see this. You're just going to do 8 times the cosine of 36. Make sure you close both of them. Open it up, 40 times the sine of 36. Make sure you close both of them. Answer is 152.2. Okay? The area is 152.2, whatever the units were squared. I don't feel like looking. Okay? So remember, make sure you type it in the calculator correctly. If you type it in correctly, it'll give you the right answer every time. Alright, so again, we had to do cosine to get the apothem. 8 times the cosine of 36 gave us the apothem. And then we had to find half of the side length, which is 8 times the sine of 36 equals x. And of course, since we have 10 halves, because we have 5 sides, each side has 2 halves. So 2 times 5 is 10, so we have 10 halves. 10 times 8 times the sine of 36. The 10 times 8 becomes 80. You can half the 80 down to 40. And then make sure you punch it in the calculator correctly, and that'll give you the 152.2. And that is not a rounded answer. That is an accurate answer. Okay? Alright. Turn it over. Let's do 15, and that looks like the last one on this page. Alright, number 15. We have 2 triangles. It tells us they're similar. This is 14 feet. This is 8 feet. It wants the perimeter ratio and the area ratio. Remember, for the perimeter ratio, you just stick the side lengths. Stick 2 corresponding side lengths over each other. So we're going to do the 14 over 8, which if you pull a 2 out of both, that'll go to 7 over 4. So our perimeter ratio is 7 over 4. All I did was 14 over 18, pulled a 2 out of the top and bottom, 7 over 4. Now, to get from area to perimeter ratio, you take your perimeter ratio, I'm going to call it x, and you just square it. Okay? So, 7/4 squared, remember you square the top, over, you square the bottom. If that could be reduced, you can reduce it. If it doesn't reduce, just leave it like it is. 49 over 16. Alright, so your perimeter ratio is 7 over 4. Remember 14 over 8. Reduce it down, 7 over 4. Don't make this a decimal, leave it as a fraction. Then you just take this and square it. 7 squared is 49, 4 squared is 16. Alright, so that's your answer to 15. Your perimeter ratio and your similarity. I'm sorry, your perimeter ratio and your area ratio. Alright? Now we're going on to part B. So put that page down and pick up your other one. At the bottom it should be page 87. We're doing number 2. We have a triangle. This is 118 degrees, 9 and 6. Now remember, this is that formula I gave you in class. It's got to be 1/2 a side times another side times the sine of the angle in between. Remember, this angle has to be, it is a requirement that it is the angle between those two sides. Okay? Has to be, has to be, has to be. Well, if you notice, the 9 and 6, the 118 is between the 9 and 6. So we're set up here to go. So it's just simply 1/2, 9, 6, sine of 118. If you want, you can half the 6 down to 3. So 9 times 3 is 27. So 27 times the sine of 118 is 23.8. And then, of course, meters squared, because that was the units. And that's it. That's all you got to do. Alright? Now, 1, 2, and 3 all work the same way, because you can see you have the side and two angles. And I mean, you have the angle and the two sides on either side. So you just plug it all into this formula and you're good to go. Alright? Number 8. Number 8 deals with this circle right here. Alright, what is the circumference of that circle? Well, circumference equals 2 pi r, or pi times diameter. Well, if you notice, we have the radius. Radius is 18. So we're going to do 2 pi times 18. 18 times 2 is 36 pi. And it wanted our answer in terms of pi, so there you go. Since it wanted your answer in terms of pi, you just leave the pi there. You never actually multiply by it. Okay? You never actually multiply by it. You just leave it there. Just leave it there. Alright? Number 12. A circle has a diameter of 12. What is the area of the sector determined by a 60-degree arc? So here we go. 60 degrees. So we want to find this area. If the diameter is 12, which means the radius is 6. Okay? So what you have to do here is you have to do the measure of arc AB divided by 360 times pi r squared. So the measure of your angle, 60 degrees, 60 over 360 times pi, 6 squared is 36. Those cancel. The 6 and the 36, this goes to a 1 and a 6. So this is 36 pi over 6. That goes to a 1, that goes to a 6. 6 pi inches squared is your answer. Okay? So you just got to remember this formula. The area of the sector, because remember this is a sector, it's like a slice of pizza. That's your sector. It's the measure of your arc. Remember, the measure of your arc is the same as the angle that creates it. So 60 over 360 times pi r squared. R is 6 because the diameter is 12. So you're going to do 60 over 30 over 360 times pi times 6 squared, which is 36. Remember, the zeros cancel. And then the 6 and the 36 go to 1 over 6 times 36 pi. So this is simply 36 pi over 6. The 36 and the 6 cancel to a 1 and a 6. So all you're left with is 6 pi inches squared. All you're left with is 6 pi inches squared. Alright? Let's go on to 14. We have a circle. This is 90 degrees. This is 12. And we need to find the measure, the length of this arc. Okay? Remember, the length is the walking distance. If you were to start here and walk along this circle to here, the length of that is how far you walked. The measure is simply whatever this angle is. Okay? So remember, measure equals an angle, whereas length equals distance. Okay? Length equals distance, whereas measure equals an angle. So for this, you're going to do the measure of arc AB over 360 times 2 pi r. Or if we had diameter, this instead of 2 pi r, it'd be diameter times pi. Depends on what you have. Okay? Let's think about it. 2 pi r, 2r, that is a diameter. Okay? So the measure over arc is 90. How do we know? They told us. Times 2 pi r. R is 12, so this is 24 pi. Alright. The 90 and the 360 go to 1 over 4. So this equals 24 pi over 4. That cancels with that. 6 and a 1. So 6 pi inches. The reason this is not inches squared is because it's just a length, it's not an area. Alright? So, for the length of the arc, you just got to remember this formula. The measure of the arc divided by 360 times the circumference of the circle. This gives you the circumference. So you figure out what piece of your circumference your arc is, and then you multiply that by your circumference to find the length of it. Alright? Turn the paper over, let's do 16. We're going to do 16, 18, and 21 and be finished. Alright, 16. We have a segment A to D. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Alright, B is at 3. C is at 5, and this is 0 and 10. Oops, I put these in the wrong place. Alright, there we go. So we want to know what the probability is if we were to throw something at this line and we were guaranteed to hit the line. What's the probability that it would land between A and that would land on the segment AC? So remember, it's what you want over all the possibilities that can happen. Okay? Well, what you want to land on this segment right here. What's the length of that segment? Well, it's C minus A, 5 minus 0, so 5. Over the length of the whole line. What's the length of the whole line? 10 minus 0, which is 10. Okay? So what you want is to land on this segment that has a length of 5. But what could happen, it could land anywhere on this segment with a length of 10. So what you want over what could happen, that's 1/2. Convert that to a decimal. Convert that to a percentage. You have a 50% chance of throwing something at that line and hitting AC. Alright? Because you're going to hit the line. And you have a 30% chance of hitting AC. I mean a 50% chance of hitting AC. Alright? Remember, what you want to happen over everything that could happen. Alright. 18. We have a circle with an inscribed triangle. This is an equilateral triangle. The radius of 10. And the triangle is shaded. We want to know, if we were to throw a dart at this circle, what would be our chance of hitting the triangle? Alright, and they actually want us to leave our answer in simplest radical form, so we're not going to put this in a percentage. We're going to leave this as an actual answer. Okay? So what you have to do, what we want is hit the area, is to hit somewhere in the triangle. What could happen? It could hit anywhere inside the circle. So we're going to put the area of the triangle divided by the area of the circle. Alright? So let's go ahead and get the area of the circle. Well, the circle has a radius of 10. So pi r squared, so that's 100 pi. So that's the area of the circle, 100 pi. Area of the triangle, we got to drop this down. We know that this angle here is 60, which makes this 30 and this 60. Alright? Now, this here, since it's across from the right angle, that's our 2s. Let me get rid of this. That's our 2s because it's across from the 90. So 10 is 2s. Well, if 10 is 2s, what is s? Well, 10 divided by 2 is 5. So s is 5. So our apothem is 5 because that's what's across from the 30. Now across from the 60 is s times the square root of 2. Well, what is that? Well, since s is 5, that's simply 5 times the square root of 3. So this is 5 times the square root of 3. So now we have everything we need to find our area of our triangle. Area of a triangle is 1/2 AP, 1/2 A. Perimeter, remember, you have 3 sides, so we have 6 halves. So that means this is 30 times the square root of 3. If you want, you can have the 30, down to 15. So now, 5 times 15 is 75. So this is 75, square root of 3. Now, we can reduce this. Okay, we can reduce this. If you take a 25 out of here, you get a 3. Take a 25 out of here, you get 4. So our final answer is 3 square root of 3 over 4 pi. Alright, remember, area of the triangle divided by area of the circle. Area of the circle is simply pi r squared. R is 10. 10 squared is 100 pi. Find the area of the triangle. The apothem is 5. This side of the triangle is 5 square root of 3. But remember, this is also 5 square root of 3. Which means this whole side length is 10 square root of 3. And we have 3 of them. So that's where the 30 comes in. 30 square root of 3 is the perimeter. Okay, if you want, you can half the 30 down to 15. 5 times 15 is 75 square root of 3. You can pull a 25 out of both of these numbers. That'll take it to 3/4. Okay, so 3 square root of 3 over 4 pi. That is left in simplest radical form. Do not go any further than that if it says simplest radical form. So this here is the probability of hitting the shaded area, which is also the probability of hitting the triangle. Okay? Alright, now let's look at 21. For 21, it's also going to help you with 20 because it's an identical problem, just different numbers. It's also going to help you with 19 because we're going to have to find the sector in order to find the crust. Okay? So for 21, and I'll show you what step helps you with 19, don't worry. Here's our circle. This is 12 feet. We know this is 60 degrees. And we want to find that. Alright? So to find the area, that's called a segment, don't forget that. Area of the segment equals the area of the entire sector minus the area of the triangle. Okay? So this first part I'm going to do is also how you would do 19, just with the numbers from 19. Okay? So, to find the area of the sector, which 19, you're finding the area of a sector, it's the measure of your arc AB over 360 times pi r squared. So the measure of our arc is 60 over 360. That's 360. Let me write that better. 60 over 360 times pi. Radius is 12. 12 squared is 144. Zeros cancel. This goes to 1 over 6. So this is 144 pi over 6, which you can pull a 3 out of that. Actually, you can pull a 6 out of that. This comes down to 144 divided by 6. That's a 1. This is 24. This goes down to 24 pi. So 24 pi is the area of the whole segment, which is what you're trying to find in 19. I mean the whole sector, sorry, which is what you're trying to find in 19. Now, to find the area of the triangle, let's use that new formula, 1/2 the side times the side, because we know this angle is 60. Alright, now, this is a radius, right? Well, isn't this a radius too? So this is going to be 1/2 radius times radius, or radius squared, times the sine of your angle, which is from your arc. Okay? So this is 1/2, 144, times the sine of 60. Okay? So you can half this, what is that, 72? So 72 times the sine of 60. The sine of 60 is the square root of 3 over 2. Alright, so we're going to write, I'm going to have to erase some stuff here to write. Alright, I'm going to erase this. I'm going to leave the answer so I know what it is. So now, to find the area of the segment, we're going to take the area of the sector and subtract from that the area of the triangle, which is 72 times the sine of 60. Okay? So, just punch it in your calculator, 24 pi minus 72 times the sine of 60. And you should come up with 13.04. And whatever the units were, feet squared. Alright? So, just to review what I did. Area of the segment, which is like the pizza crust, is the area of the entire sector, which is like the slice of pizza, minus this triangle. So to do the sector, I erased the formula, but the area of the sector, remember, is the measure of your arc AB over 360 times pi r squared. So this is 60 over 360 times pi times 144. That reduces down to 24 pi. Then you find the area of the triangle, which is 1/2 r squared times the sine of your angle. So 1/2 144 times the sine of 60. 1/2 into 44 makes the 44 72. So the area of the segment is 24 pi minus 72 times the sine of 60, which comes out to 13.04, and then of course feet squared. Alright? So this has been your chapter 10 review. You can watch this as many times as you need to. Make sure when you come to class tomorrow, you're ready to take the exam. See you tomorrow.